Okay.
All
So
right.
whenever we are going to solve a problem with the computer, okay, we need two things. We need processors and we also need the memory. Okay, these are the two resources that can be assigned to solve a particular problem. This is very
Okay.
natural. You can say that this is very natural. Now you can think without a machine. If you are asked to solve a mathematical problem, you will take some paper pencil, okay, and you will write the problem, you will write the data, you will write the values, okay, and then your brain will be processing that one as a central processing unit, okay. So your hands, your eyes, they are your input and output devices, like your input and output devices. Your brain will be like your central processing unit, okay, and the paper on which you are writing the values, you are processing the data, you are multiplying, all these things are being done on your paper. So that will be the memory area, working area, where actually you are performing where you are actually processing your data to solve the solution of that particular problem. Understand?
Yeah. Yes.
So different mathematical problems exist around the globe, okay? And similarly, different mathematical problems exist in you can say in computing, okay? So for different problems, the researchers had developed that different way of organizing the data help in effectively, okay? There is no single way of data. Sometimes we can, I give you a here example, data structures. And if I show you the images, you will see here different type of images, okay? Yes, the first thing you need to know, so there are two type of basic data structures. One are called primitive data structures. Second one are called non-primitive data structures. Primitive data structures are that we can store the values integer, float, character, boolean, string. These are our primitive data structures. Okay.
Okay.
And non-primitive data structures that have been developed. Okay. I mean, when a language is created, okay, it carries primitive data types, okay. These primitive data structures are called data types, okay. Like Java has some data type. You can say that Python has certain data types, but these are not necessarily be the part of any language compiler, okay. But they can be developed, okay. So they all support all non-primitive data types. What are these? These could be linear and non-linear. When we talk about linear data structures, it means that you will store the data, but there will be some sort of order while you are storing the data. Understand?
Yeah. Yeah.
But when we talk about non-linear data structure, they are such type of organized way of data. They are organized, but for storing and retrieving, you do not need any particular order to get in the value or to retrieve the value. Understand?
Okay.
I show you another example here. For example, stack and queue. Okay, they are the most popular way of data structures. Okay.
Okay.
Now you can see here the figure about stacks and the queue. Look at here. This is our real life. This is stack in real life. Okay. For example, we put the books in this way. Okay. So we can see here when we are storing the books, we are storing the books one on the top of other. Okay.
Yeah.
The book that we stored very first is on the bottom. Okay.
Yeah.
The book that we have stored at the last is on the top. Okay.
Okay.
And whenever we are going to take the book, for example, to retrieve the value from this collection of books, you will see that we will find out the last book that we have stored there. Understand?
Yeah.
So this is called last in, first out. Okay.
Okay.
The value you put last, the value that you will put last in your stack will be retrieved first when you will want to get that value. Okay. The value which you have put on the very first, it will be retrieved from that value in the very last. Okay. You can think about this one. Okay. We are storing 1, 2, 3, 4, but when we will pop that value, you can see that 4 will be popped out. The top value will be popped out, not other. So this is a way of storing the books. Okay. This is a way of storing the books. But we know that we can also have some examples like queue. What is queue? You can see this is queue. Okay.
Yeah.
This is the real. So you can see that from this way they are entering in the queue, and from this way they are exit from the entry queue. Understand?
Yeah.
So this is another way of storing of data. If you are going to store some data in this format, okay, that you have one way entry and the other way to the exit. Okay. And what it means that the value that you will put very first in the queue, when you will push the second, that will be on the right. Which value will be retrieved from the queue? The first value.
The first one, yes.
Okay, so this is called FIFO. Okay, first in, first out.
Out. Okay.
So you can see there we can store if we change the way of organizing the data. We know that we got another scheme of data saving and data retrieval. Okay. For here, you can see that we have a front that is going to be the front part from where we will exit or we will get the value. This is the rear from where we will enter the value. Understand? So entering the value into the queue is called NQ. Getting the value from the front of the queue is called DQ.
DQ.
Okay. And what is the what scheme it supports? It supports first in, first out. The value that will be stored first will be retrieved also first. Understand?
Yeah.
So similarly, the actual data structure that we are going to discuss today, that is linked list. Okay. Linked list. This one, another, you can see here, array is the first one. That is very natural. We have discussed. You can see that we have a collection of elements there. We can add the value to the array, but we know that array cannot be, you can see that we cannot change the size of array. You remember that? If we declare an array of 100 elements, so we can put 100 elements, but we cannot extend. So this is called basically static data structure. Okay, but you seen that when we talked about the array list. Okay, in Java, there is no such restriction. Okay, we create the array list, and whenever we want to add the value, we can add, and as much as we want to add value, we can add. Okay. Look at here, we can create the array list and we can add the value using the add. So this is a special type of data structure, arrays and list. Okay, the difference between array and list is this one. Okay, array is a static type of memory allocation, while list can dynamically allocate, can be appended, can be extended. Understand?
Yeah.
So look at here. This is also written here. List, dynamic, array. Okay. Queue is also based on array based, and we will also see that map and vehicles, some special type of data structures as well. So after array list, we are going to discuss array list was also a special type of data structure that implements the list data structure. Okay. The list data structure. Okay. So we have a special type of list that is called linked list. Okay, that is called linked list. Linked list is a special version of a list data structure.
Okay.
Now you can see that this is linked list. Okay, you can see there this one is called an element. Okay,
Okay.
but we call it in the linked list. This is a single node. Okay, this is a node. Okay, for example, one
Okay.
element. This is the second element. Okay, this is
Okay.
the third element, and this is the last element. How I said that this is the last? Look at, this is the first element. How I know that? Because the head is pointing to the element number A. Okay. So
Okay.
what will be your first element in the linked list? The element to which head is pointing to, okay, will be your
Okay.
first element.
The first element.
Okay. And what will be the last element of your linked list?
The bottom.
No, which one is pointing to null? Okay, you can see here.
Oh yeah.
A is connected with B, B is connected with C, and C is connected with D. But D is not connected with anyone. You can see here. Okay, D is not connected with this one, and it is connected with null. You can see here. Okay, so an element which contains, which do not contain the, which is not linked with any other element. Okay, or which contains the null pointer. Okay.
Okay.
In its connecting part, so we say that this is the last element. Okay, you can also see here, this is the element number 15 and had stored the address of 3200. This is the address. Okay, and this elements has the, this node has two things. Okay, look at every node or every element in a linked list is consists of two things. Okay, one is the value that it holds, and the other one is the address of the next element to which it is linked. Okay.
Oh, okay.
For example, look at, this is 3. Okay, 15 is connected with 3, 3 is connected with 17, 17 is connected with 90. Okay, like A connected with B, B connected with C, C connected with D. Okay.
Okay.
Look at here, this 15 is connected with 3. This 3 node is stored at 3600. So the address is written here. Okay.
Okay.
Okay. 3 is connected with 17, and this node, it has the address 4000. You can see here 4000 is stored here. Okay.
Yeah.
And this 3 is connected with the 17 is connected with the 90, and the address of 90 is 44. So the next pointer, we call it next. Okay, we call it, this is the next. Okay. Next. Okay. Yes. So this is called the linked list. Now look at here, 90, which is to which element or node 90 is connected. If we see the address part, we see here null. It means this is the last element.
Okay.
Okay. And whenever we will add the element. For example, we are going to add an element. Okay.
Okay.
Let's suppose we want to add in linked list. What will happen? You can see here. Okay. You can see here this one. I want to clear all the drawings here, and you can see here. This was the B variable. You can see the address of these nodes will be updated. Okay. Okay. Yeah. This value is going to be inserted. So this link will be broken. This you can see here. Okay. Okay. Yeah. Okay. In this way, this is connected. This was connected to this one. This was broken. And now B is connected with E, and E is connected with C. So it means that this E has been added to this linked list. Okay. Okay. We can add at any location in the linked list. This is the main difference between array data structure and a list data structure. Okay. In array, we cannot add at any specific location. We will have to add at the end of the array. Okay, but in linked list we
Yeah.
can add at anything. So this is basically the function of the linked list. You understand this?
Yeah. Yeah.
This is the overall concept of whenever you are going to read a data structure, what three things you need to learn about a data structure. Okay, whenever,
Okay.
for example, you are going to learn stack, you are going to learn queue. So what three things? Number one, you need to learn how data is represented in the memory. Okay, and we have seen
Okay.
that. We have seen that every linked list has a node, okay, which has two parts. One is value, and the other is the next, okay, which contain the address of next one. Okay, this is memory representations. Understand?
Okay. Yeah. Yeah.
So the second thing we need that how to perform different operations on this. Okay, like we see that how to add value in the list stack, and how to retrieve the value from the stack. Okay, I give you
Yeah.
examples that we see that in the stack we can add from the one end, and we can we can get from the same end. Okay, remember
Yeah.
that? Yeah, stack,
Yeah. Yeah.
stack, push and pop. Okay, these operations are called push and pop. Look at here, this is stack, this is empty stack. Now this is push one. Okay, when we insert a value into the stack, this operation is called push operation. Okay,
Okay.
so here we push the value one. Okay, here we push again value two, here we push again value, and when we are getting some value from the stack, or we are retrieving the value from the stack, this operation is called pop. Understand?
Yeah.
So this is also so if someone asks you what is the how to insert a data in the stack, the simple answer is that by push operation. Okay,
Okay.
how to retrieve data from a stack? The answer is pop function. Understand?
Yeah. Yeah.
So whenever we are going to study any data structure, we need its memory representation. Okay, we need its operations. What are different operations that can be performed? So we can see here what is the memory representation to create a linked list. Okay, we need a head pointer. Okay, understand?
Yeah.
Which will contain the address of first element. Okay, understand?
Okay.
First element are node. In some books it is called node, and in some books it is called element. They are same. Okay,
Okay.
then we need an element R node. Okay, okay,
Yeah.
which have two things, one for value, one part for value part. Okay, the other is for next pointer. Okay, which contain the address of the next one. Understand?
Yeah.
The third one is we can say that which we have learned that the null pointer in the next, okay, indicates that this is the last element. Okay.
Okay.
And what operation we can perform? We can perform the add element operation. Okay, we can perform the remove element, we can perform all the other operations like get first, get last. These are primitive operations that can be performed on linked list data structure.
Okay.
Understand? So here is the linked list data structure in the Java. We have a utility class that is called a linked list. Okay, the same way we can define here linked list cars and a new linked list. This list is created now. Okay, internally every element will have the connection with its next element. Understand?
Yeah.
Okay. So you can see here, these are the different operations that can be performed on linked list. We have the add first, we have the add last, we have remove first, remove last. Okay. We can also have get first and get last. Okay.
Last.
So if we
Okay.
try it here, we can see the code example. Look at here. Here we have the linked list, and you can see here I am going to comment this and I run this. Okay. Here we are creating the linked list car. Okay. And here
Yeah.
we are just adding an element, because this element is adding to an empty linked list. So Volvo will be the first element. Okay.
Okay.
Then we will add BMW, because we have the Volvo is the first element. So BMW will be added after Volvo. Understand?
Okay. Yeah.
And here we have the Ford element. Okay. So after the BMW, so this will look like this one. You can see here. Okay. When we print
Okay.
this linked list, we will see that Volvo, BMW, and Ford is added. Understand?
Yeah. Yes.
But we know that we have a function that is add first, adds an item
Add first.
into the beginning of the linked list. Okay. Now we call this
Okay.
function. Look at it. Cars dot add first and this Mazda. Okay. And
Okay.
we run this, and you will see the list that this item has been added in the beginning of this linked list. You understand?
Okay.
You look
Yeah.
at it. Now Mazda has been added at this. Similarly, we try add last, and you can see here the same thing is happening here. Okay. We are adding the add last Mazda, because this is quite natural, but this function can be called to add a value whenever you want to add at the last of your linked list. Understand?
Yes. Yeah.
Similarly, we have the function remove first. Now we have Volvo, BMW, Ford, and we are going to commit this one. And before removing the first element, we can see the output. You will see the output that Volvo, BMW, Ford, and Mazda. Okay. Now, if we will run like here, we run the cars dot remove first. Okay. I am going to copy here and I am pasting here. And after that, I am going to print this list again. Okay. You can see here. Now you can see. Okay. If we run this, look at this was before removing the first element, and this list is after removing the first element. You can see here we are removing the first. So you can see here remove first is also working. Okay.
Okay.
Okay, understand? Then we have the get first. Okay. Similarly, we can use the remove last. Now we try the get first. What is get first? This is our list. Okay. And we are getting the first one, car dot get first, and you will see that the first element is retrieved. Okay. And if we use here get last, we run it, you will see that the last element, and which is Mazda. Okay, it will be printed. It must be printed here. Okay, you understand? So this is the built-in class and built-in utility class of linked list in our Java. You can see here. Okay. Let me see whether we have some other functions with linked list or not. Okay. Linked list in Java. This is linked list. This is some other link we have, that is the geeks for geeks. Okay. We have the linked list class. We can also create with the collection. We are not look at here. This is add, to add an element at the given index. Okay. these are the different functions. Okay.
Okay.
Like we were adding here, this was add last, and this was add first. Okay. After this, we add here cars dot add, and we put here what is the syntax here. The syntax is first of all give the index and then the element, and then element. Okay. So we put here like 2 comma, and then we put here like colon. Okay. Yes.
Okay.
And put semicolon, and then again try to print this one, and let's check that. So these are the functions that can be worked. So we have add in 2 formats. Okay, you remember that?
Okay. Yeah.
The function of overloading. Okay.
Yeah.
The name will be 1, but the number of parameters can be changed. Okay?
Parameters.
Yeah. This is this was the core functionality of object-oriented programming. You can see here, this was our first element. This was our second element. Now we have added at the position 2. Okay, 0, 1, and 2. Okay.
2. Yes.
So this value has been added at here. Understand? We have add for the 2, and we have also add all function. Okay. What will be that if you have a collection of elements there? Okay. Okay. Then you can add all the elements, insert all the elements in the specified collection into the list. Okay. For this, you will have to import the collection class. If we click this one and see how it is adding, I must believe that we will have to declare a collection first. Like this is linked list, this is list. Okay, these are the values added. Look at here. This is collection. This is a collection that is generated. Okay, with the collection class. Because we have not discussed the collection class. That's why you might get confusion. But if you have a collection class, understand?
Okay.
As an array list. Okay, look at here. And this a computer porter for the geeks, 1, 2, 3, 4, 5, and you are calling on the linked list add all and passing a complete collection object. Okay. It can add all of these objects. We try here where we was trying. For example, I don't think it will work for us or not, but we should try this one here. Okay, we are creating a collection here, and then we call this function. Okay, this is the collection. We are going to call here this collect, and then we are going to print here again. Okay, one thing we need to import here, util.linkList, util.ArrayList. Okay, we have to include this one here. Okay, where we are doing this one. So we import all of these. We run it, and let's check that. Definitely it will work now. You can see a list. Okay. We have the object named cars. Okay.
Yeah.
Understand?
Yes.
And you will see here that all collection at the same has been added here. Okay. Computer portal, a complete collection. This was another collection. Okay.
Okay.
And the whole collection is added at the end of this linked list. Understand?
Yeah.
Okay. Now the next function is, this is how we can know. Add first, we have the add first with the element. Okay, we have add last with the element. If we will clear, then all the method will clear all the nodes. If we are going to clone the linked list with someone else, okay, this is called the shallow copy of the linked list. There are 2 types of copies. I think that we have discussed this concept when we were discussing object-oriented programming. You remember that we have discussed shallow
Yeah.
copy and deep copy.
Yes.
Okay, so this is about the clone. Okay, if you are going to
Okay.
clone two linked list, okay, but these lists will be cloned with a shallow copy. Okay, this is mentioned here. Okay, one is going to be cloned in the second one. You can see the code example here. Okay, this is the complete list of functions and methods for the Java linked list class. Okay. And you just need to find out the index you need when we use, for example, some editor. Understand? We know that in the editor we have the list of all the functions there. Okay, like Eclipse and someone else. But here, because we are doing in the W3 school, so that's why we are not getting the editor here. Okay, so this is the example of clone, linked list dot clone. For example, we have a linked list with the name list, and then we are creating a second list. This is also the linked list. So this is how you can clone a linked list with some other linked list. Understand?
Yeah.
So I am going to implement this one and going to show you the concept here. Okay, look at here. This is our second list. Okay, and we clone this second list with our first list that is of cars. Okay, understand?
Okay.
And then we print our this second list. Press here second underscore list. Okay, so run it, and we will see that the same elements will be printed. Where is we have? I think yes, this is missed. Okay, second list is equal to cars dot clone and system dot out dot second underscore list. Okay. Now we will see this one. You can see here, okay, the same list is here. This is the second list. Understand?
Yeah.
Now, one thing I should practice here, that is adding another element in the first list. Okay, so we are going to add here, and this is test shallow. Okay.
Okay.
We have added in the add list here. After that, we print both the list here. Okay, the first one and the second one. Let me check that whether this change is also in the second list or not. Okay, not. You can see here. Okay, there is no change in the next one.
The second list. Yeah.
Okay, because this is shallow before the adding of this list. You understand?
Yeah.
Okay. So these are some other functions like clone. We have the contain. This is very important function. Okay. And soon we have, I think we have worked on this one when we were working on our last example. Okay. And I am going to, I am also planning to give you a very short assignment here, okay, with the help of contains function.
Okay.
Contain function returns true if the value is contained in the element in the list, otherwise it returns the false. Okay.
Okay.
For example, we are using here and we call here, for example, system dot out dot println, and we ask here println and cars dot contains, and here pass like ZA. Okay. And we run this, so there will be an error. One more close there. Okay. It must print true. Okay.
Yeah.
Because this contains Mazda. Okay. So this is very valuable function for the linked list. Okay. It tells that whether some element is already in the list or not. Okay.
Okay.
If in some situation we want to store some element and we want to contain and we want to add an element into the list, okay.
Okay.
Before it, we want to check that whether this element has already been added or not, okay. So we can use this function. You understand?
Yeah.
So for this function and to understand this function, I needed to give you, for example, a very small assignment that create a linked list of 5 unique random numbers between 1 and 100. Okay. Okay.
Okay.
For example, you are asked to create 5 unique numbers. Okay.
Okay.
And these numbers should be between 1 and 100. Okay.
Mm-hmm.
Sorry, between 1 and 10, not 100, because when we talk about 100, these numbers can be, but they should be unique. Okay. For example,
Okay.
if you create a random number and it is created like 2, okay, you add it to the list, linked list. Okay. Second time you again create a random number and again 2 is created, because you do not know what the system is going to generate the number. Then this 2 should not be the part of that list. Okay.
Okay.
You understand?
Yeah.
So in this way, you can test the unique function, this contains function, how it can work. Okay. Okay. This is
Yeah.
also element get index. Okay. For example, this returns the element at the specified. If we give get of I, it will give that object. Okay. If we will use get
Okay.
first, get last, and similarly, we have the index of function to find the index of some particular object. Okay. For example,
Okay.
we want to print, like here we have checked that whether contains Mazda or not. Okay.
Mm-hmm.
So we put here if, and I'm going to copy this one. Yes, this one. Okay. Copy and I paste here. If cars are contain Mazda, if it contains, then you must print out its index. Okay. I want to know
Okay.
at which position this object is there. Okay. Cars dot index. What is the exact spelling? Index of O capital. Okay. O capital. Let's look at index of Mazda. You understand?
Yeah.
If this item is contained in the list, then I need to know its index. Okay. You can see here, and when I will run it, you will see now the index of this Mazda object. Okay. Look at here. The Mazda is at 3. Okay. 0, 1, 2, and 3. So this is at number 3. Understand?
Okay. Yeah.
Okay, so this is the index. These are some different functions, okay, which you can use as per your need, okay. But as a programmer and as a student, you must read all of these functions for one time, okay. You like me, okay. I do not know the exact syntax of all the functions, okay, but I know that this functionality is the part of linked list or not, okay, because I have already I have a list in the mind. Okay.
Yeah.
For this purpose, you must see once what are different functions are available in, like this one is the size. Okay, it can returns how the elements of the size are. Okay, we can also have these special type of functions like to array. If we are going to convert this linked list into an array, okay, we have to array, and similarly we can also have to string function. This is very utility function. Okay, like here,
Yeah.
we print this one here. Okay, and now I'm going to print here dot to string. Okay, let's check how this is printed. Look at here. This is the same way we are getting the output. Okay.
Okay.
Okay. This one and this one. Okay. Actually,
Yeah.
when we call this section list, this actually function is called. That's why we can print a linked list. Okay.
Oh, okay.
Otherwise, the class that you want to the object that you want to print using the system.out.println, so you must have declared the toString function inside that one. Okay, like we have made I think you had remember when we had made the product function there, product class and cart class and order class in our previous example. Okay,
Okay.
we have made there the display cart, the display product function. Okay,
Mm-hmm.
so this is like the same one.
Okay. Yeah.